In this video, we find the limit as x approaches 0 of cosine 2x raised to the 1 over x squared power. The key to doing this problem is first noticing that e to the natural log of x is the same thing as x. So I'm going to rewrite cosine 2x raised to the 1 over x squared power as e to the natural log of this whole thing. So this thing, you can think of it as x over here. So that's what goes inside the natural log. And now I can rewrite this as e to the limit because e to the x is continuous. So basically I'm going to switch spots here, e with the limit. So it's e to the limit of the natural log. Now the goal is to use L'Hopital's rule, but right now if I plug in x equals 0, I just get natural log of 1 over infinity, so that doesn't work. So why don't I use the natural log property? So whenever I have ln of x to the n, that's just going to be n times natural log of x. So the exponent here is going to be 1 over x squared, and that's going to come outside of the natural log. So we'll put that in front of the natural log. And so if I plug in x equals 0 now, I get ln of 1, which is 0 over 0. So I can apply the L'Hopital's rule to this limit. What that means is I have to take the derivative of the natural log of cosine 2x, which is 1 over cosine 2x, times negative 2 times sine 2x. And the bottom, I have to take the derivative of x squared to get 2x. So what I did was I brought this cosine 2x on the bottom here with 2x. And now I can simplify. So first, the 2's are going to cancel. I brought the negative in front of the limit. And now I split this up into two separate limits. So really what I have right now is sine 2x over x times cosine 2x, which I can rewrite this as just sine 2x over x times 1 over cosine 2x. And then I just put a limit in front of each one of these. So just using the product rule for limits. So I work it out like this. Now, as x approaches 0, cosine 2x goes to 1. So this whole thing right here, this limit is 1. So really, I just have 1 here. And then I'm just taking the limit as x approaches 0 of 2 cosine 2x. Well, cosine of 0 is also 1. So this is 1. And then I have a negative. So it's really negative 2 times 1 times 1. That's going to be negative 2. And then the base here is e. So the limit as x approaches 0 of this term, or this expression, is e to the negative second power.